You place a cobalt blue jacket on a counter, show a QR code, and watch a refund appear on your phone. From your point of view, the transaction is over, but the retailer does not have the jacket back. It may be sitting in a store that never sold it, hundreds of miles from the original warehouse. Nobody has checked whether it is clean, damaged, counterfeit, missing a button, or even the same item that was shipped, and yet the money has already started moving. That is the strange thing about a modern return. The customer-facing part can take less than a minute. The business behind it may involve software companies, drop-off networks, parcel carriers, warehouse operators, inspectors, repair technicians, auction platforms, liquidators, recyclers, and thousands of independent resellers. Some of them get paid whether the jacket is worth $100 or $10. Others only make money if they correctly guess what the jacket can still become. So this is not a video about free returns. It is not a guide to buying mystery pallets. And it is definitely not a promise that returned merchandise is easy money. We are going to follow one composite jacket through the second supply chain that begins after you click return. At every stage, we will ask two questions: who has the right to charge a fee, and who is still exposed to the value of the product? By the end, that distinction will reveal which companies are selling a service, which companies are making a calculated inventory bet, and why the person who sees the biggest discount may also be the person holding the biggest risk. To understand why an entire industry exists behind that QR code, start with the river flowing in the other direction. The U.S. Census Bureau estimates that Americans purchased about $1.234 trillion of goods through e-commerce in 2025. Online sales represented 16.4% of total retail sales for the year. In the fourth quarter alone, seasonally adjusted e-commerce sales reached about $316.1 billion. The government measures sales. It does not publish one perfect national count of every product sent back. For returns, one widely cited 2025 estimate comes from the National Retail Federation and Happy Returns. Their report projected $849.9 billion of total retail returns and estimated that 19.3% of online sales would be returned. Those numbers are industry estimates, not a scan of every receipt in America. Different categories behave very differently. Apparel can be driven by size and fit. Electronics can require testing, data wiping, or missing accessory checks. Cosmetics and food can face hygiene or safety restrictions. Furniture creates a transportation problem before anyone even asks whether it can be resold. But the direction is clear. When online commerce becomes a trillion-dollar channel, even a fraction flowing backward creates an enormous operational problem. And unlike the outbound journey, the return journey begins with uncertainty. An outbound warehouse knows what it picked. The item has a stock-keeping unit, a known condition, a defined package, and a customer address. A return center receives an object accompanied by a claim. The claim may say too small. The box may contain a worn jacket, a different jacket, or no jacket at all. That uncertainty is the raw material of reverse logistics. The job is not simply to move an item backward. The job is to convert an uncertain object into a decision before time, handling, and storage destroy more of its value. Before our jacket moves, software decides whether it is allowed to move. The return portal checks the order, date, product category, customer, payment method, and retailer rules. It may offer a refund, an exchange, store credit, a mail label, a local drop-off, or no return at all. A retailer may change those choices by item value, location, return history, season, or the cost of transportation. This first gate looks administrative, but it controls the economics of everything that follows. If a $10 product costs more than $10 to transport, inspect, and restock, the least wasteful answer may not be a traditional return. If a high-value electronic device carries fraud risk, the retailer may require serial number verification. If the product can be resold locally, sending it across the country may be unnecessary. The return software provider is usually not betting on the resale value of the jacket. It is selling decisions, integrations, customer communication, fraud controls, and routing. Depending on the contract, that can mean subscription fees, per return fees, implementation charges, or a larger bundled service. That is our first example of fee income versus inventory risk. The software company can still lose money. It has engineers, support staff, cloud costs, sales expenses, and contractual obligations. Revenue is not profit, but its business model is not based on hoping this particular jacket sells for $80 instead of $20. Fraud makes this gate more valuable and more dangerous. The NRF and Happy Returns survey estimated that 9% of returns were fraudulent. Again, that is a survey estimate, and fraud definitions vary. But the underlying problem is real enough that public companies and return networks describe verification and monitoring as part of the service they sell. The important question for a business operator is not, can artificial intelligence reject more returns? It is, can the system reduce loss without rejecting legitimate customers and damaging future sales? A fraud tool that saves $1 in false returns but costs $2 in angry customers is not a successful tool. A policy that blocks every suspicious return may look efficient inside one department while quietly reducing customer lifetime value somewhere else. The first profit opportunity, therefore, is not in saying no. It is in making a better decision earlier. Our jacket is approved. Now it needs somewhere to go. The traditional answer is a printed label, a new box, and an individual parcel traveling back through a carrier network. The newer answer is often a box-free, label-free drop-off. The customer presents a code, an employee verifies the item, and multiple returns are consolidated before moving farther. UPS says its Happy Returns network expanded to 10,000 U.S. return bar locations in 2026, putting 79% of the population within 5 miles of a location. The company describes a process that verifies items, initiates refunds, consolidates shipments, and tracks them through the network. Those are company statements, not proof that every location is profitable, but they reveal the economic idea. Density: one jacket moving alone is an awkward parcel. 50 verified apparel returns moving together can become a planned container. Consolidation can reduce packaging, simplify sorting, and give the retailer information about what is coming before the container reaches a processing center. The drop-off point: carrier, network operator, and retailer may divide the economics through contracts we cannot see. A store may accept returns to earn a service payment, attract foot traffic, support another brand, or strengthen its relationship with a network. The actual benefit depends on counter time, floor space, employee training, error rates, and whether visiting customers purchase anything. This is where online business videos often make a bad shortcut. They see 10,000 locations and imagine 10,000 passive income machines. But a location is not a business model. A contract is a business model. To evaluate a return drop-off service, you would need to know the payment per item or other compensation, average employee minutes per return, peak hour congestion, storage space, pickup frequency, loss responsibility, and the value of any additional store traffic. Without those numbers, become a drop-off point is an activity, not an opportunity. The transportation company has a similar distinction. It can earn revenue per parcel, container, route, or contract, but its margin depends on route density, failed pickups, fuel, labor, facility handling, and claims. A truck filled with predictable consolidated returns is different from a driver collecting scattered single parcels. The customer experience is convenience. The network is trying to manufacture density. And density is what turns a collection of inconvenient objects into freight that can be processed economically. The jacket reaches a return center. This is where uncertainty becomes labor. A worker or automated system must identify the item, confirm it against the return authorization, inspect its condition, and choose a disposition. The jacket may need lint removal, steaming, folding, a replacement bag, a new label, photography, or a more detailed authenticity check. For a laptop, the same gate might include powering the device on, testing components, confirming the serial number, wiping customer data, grading cosmetic damage, and matching the charger. For a power tool, it might include a safety test and battery inspection. Each category creates a different combination of skill, liability, and speed. Large contract logistics companies openly sell these capabilities. GXO, for example, describes services including warehousing, fulfillment, reverse logistics, packaging, labeling, aftermarket support, and inventory management. Its filings explain that contracts may include fixed consideration for facilities and equipment, cost reimbursement, per-unit pricing, and time and materials pricing. That disclosure does not tell us the price of processing our jacket. It does something more useful. It confirms that reverse logistics can be sold as a contract service with several different billing mechanisms. The processing center is paid to remove uncertainty at an agreed speed and quality level. Imagine two identical jackets arrive in resellable condition. One is inspected today and returned to available inventory before the season ends. The other sits in an unopened carton for 8 weeks and is finally graded after the retailer has marked the style down. Physically, the jackets may be identical. Economically, they are not. This is why speed can preserve value. The product is decaying on a commercial clock even when it is not decaying physically, but faster processing is not free. Peak periods require more stations, more temporary labor, more training, more space, and better forecasting. GXO notes that e-commerce demand creates seasonal surges and that warehouse operations carry labor, rent, utilities, maintenance, transport, supplies, and technology costs. In 2025, direct operating expenses represented 84.9% of its total revenue. That percentage is not a margin estimate for returns. GXO is a global company with many services, but it is a useful warning. Logistics revenue can be enormous while the operation remains cost-heavy. For a smaller operator, the opportunity is rarely build a general return center. The more realistic question is whether one narrow category has a grading problem that a specialist can solve better. Could a local company test and wipe returned laptops for regional retailers? Could it photograph and catalog bulky home goods before auction? Could it clean, inspect, and repackage one kind of commercial equipment under a repeat contract? The attractive part is the service fee. The dangerous part is promising an outcome without understanding the category, the error cost, and the liability. If a worker accidentally grades a damaged jacket as new, the item may return to a customer and come back again. If a technician fails to erase data from a device, the problem is no longer a simple return. If a battery is handled incorrectly, the warehouse has a safety issue. The grading table is where operational knowledge becomes valuable because mistakes travel forward. There is another way to understand the pressure at this table. Every return is running on 3 different clocks. The first is the customer clock. The customer wants a quick answer, a clear refund, and no argument about a product they believe they have already given back. A slow or confusing process can turn one return into the loss of a future customer. The second is the merchandise clock. A fashionable jacket can lose value when the season changes. A sealed electronic product can lose value when a new model launches. A damaged package can become more damaged every time it is opened, moved, or stacked. This clock determines how much value is still available to recover. The third is the warehouse clock. Every unprocessed item occupies space, requires tracking, and competes for labor. A pile of returns may look like inventory on a balance sheet, but on the floor it can behave like a queue of unanswered questions. These clocks do not always agree. Instant refunds can satisfy the customer clock while increasing fraud exposure. Detailed testing can protect the merchandise decision while slowing warehouse throughput. Shipping every item to one central expert facility may improve consistency while consuming transport cost and valuable days. The best operating system does not simply maximize speed, it spends time where time changes the answer. A 5-minute inspection is valuable if it moves a $200 product from liquidation back to primary inventory. The same inspection may be wasteful on a low-value accessory whose best route was obvious from the beginning. That is why category rules, good data, and exception handling matter. Automation should clear the obvious cases. Skilled people should work on the uncertain cases where judgment can preserve enough value to pay for the judgment. When an operator understands all 3 clocks, it can sell more than labor. It can sell faster recovery, fewer bad grades, lower storage pressure, and a better match between each product and its next destination. Once the jacket has been identified and graded, it needs a destination. There are many variations, but 4 broad paths explain most of the economics. Path 1 is return to primary inventory. The jacket is clean, current, complete, and eligible to be sold as new. This is usually the highest recovery route, but it is not free. The retailer refunded the first customer, paid for reverse transportation and handling, and now needs another buyer. It may also pay for a second outbound shipment and face a second return. Path 2 is open box, refurbished, or discounted resale. The jacket may be missing original packaging or show minor evidence of handling. An electronic product may work perfectly but cannot honestly be sold as factory new. The retailer or a specialist channel reduces the price to match the condition. This route exchanges margin for speed and transparency. A clear condition grade can create a buyer. A vague grade transfers uncertainty downstream and usually demands a larger discount. Path 3 is return to vendor. The retailer sends the item back to the manufacturer or distributor under the commercial agreement. Who pays transport, who receives credit, and what condition qualifies are contract questions. This can move the inventory problem off the retailer's books without making the physical problem disappear. The vendor still needs to inspect, repair, resell, recycle, or dispose of the item. Path 4 is an alternative channel: liquidation, donation, parts recovery, recycling, or disposal. This is where the gap between retail price and recoverable value becomes visible. Consider an illustrative jacket originally priced at $120. Assume, only for demonstration, that the retailer's merchandise cost was $38. Now add $6 for return transportation and consolidation, $4 for verification and grading, $3 for cleaning and repackaging, and $2 for extra systems and storage. Those figures are not industry averages. They are variables in a model. If the jacket can be sold again for $120, the retailer has preserved far more value than if it is sold open box for $78 or liquidated for $18. But even the full price route carries the extra $15 in our illustration, plus the original outbound fulfillment, payment processing, marketing, second shipment, and possibility of another return. The first sale was refunded. The second sale is not free money. The real decision is whether spending another dollar on the jacket is likely to recover more than $1 in additional value. That is why disposition rules matter. A company that spends $10 testing a product only to improve its recovery by $5 has performed useful work badly. A company that throws away a product that could have been restored for $2 has avoided labor by destroying value. The best route changes with product price, condition, season, shipping distance, channel restrictions, and the confidence of the grade. Reverse logistics is therefore a decision business disguised as a moving business. Now suppose our jacket cannot return to the retailer's normal inventory. It is grouped with other returns and placed into a liquidation lot. The lot may be sold by the retailer, a marketplace, a liquidator that works on consignment, or a company that purchases inventory and resells it. Those models look similar on an auction page but carry very different risks. Liquidity Services offers a useful public example because its filings describe several ways the company earns revenue: transaction fees charged to sellers or buyers, proceeds from products it purchases and resells, and value-added service charges. Its services include inventory tracking, cataloging, inspection, grading, testing, data wiping, refurbishment, delabeling, logistics, and disposition outside its marketplaces. In fiscal 2025, the company reported $1.6 billion in gross merchandise volume and $477.7 million in revenue. Those figures are not a profit claim, and they are not limited to customer returns. The company also handles government surplus, industrial assets, and other categories. But the disclosure shows three distinct business models hiding under the word liquidation. First, a marketplace can collect a fee for connecting supply with demand. Second, a service provider can charge for preparing, testing, listing, and moving the inventory. Third, an inventory buyer can purchase the goods and hope the resale proceeds exceed every cost. The first two models primarily sell a service. The third model makes a bet. Official retailer liquidation pages show how that bet is packaged. Walmart's liquidation marketplace, for example, lists excess inventory, store returns, and refurbished merchandise in lots ranging from pallets to truckloads, often below original suggested retail prices. The phrase "below retail" sounds like margin. It is not margin. Suggested retail price is not the expected selling price of a mixed, returned, incomplete, or outdated product. A pallet buyer must subtract inbound freight, unloading, missing units, broken items, testing, cleaning, storage, marketplace fees, customer service, refunds, sales tax administration, labor, and the time required to sell dozens of unrelated products. A pallet with a listed retail value of $10,000 is not a $10,000 asset. It is a collection of uncertain recovery values. This is where risk is transferred. The retailer receives cash and clears space. The marketplace receives a fee. The freight company receives transportation revenue. The buyer receives the upside and the unsold inventory. That does not mean liquidation buyers cannot succeed. Specialists with category knowledge, inexpensive space, strong resale channels, and disciplined bidding can create value. But their advantage is not access to cheap goods. Their advantage is being better than competing bidders at estimating recovery after all costs. If you cannot inspect the merchandise, estimate the sell-through rate, price the labor, and survive a bad lot, the discount is not your profit. It is compensation for accepting uncertainty. We can now answer the question in the title, but the answer is not one company. The software provider can profit by making authorization, routing, exchanges, and fraud decisions more efficient. Its unit is a subscription, a transaction, or an integrated service, not the resale price of one jacket. The drop-off and transportation network can profit by creating convenient collection points and enough density to move returns efficiently. Its units are locations, parcels, containers, routes, and contracts. The processing center can profit by receiving, verifying, grading, cleaning, testing, repackaging, and routing goods under a contract. Its units are processed items, labor hours, facilities, and performance targets. The repair or refurbishment specialist can profit when its skill increases recovery value by more than the cost of the work and any warranty exposure. The marketplace can profit from transaction fees and services when buyers and sellers complete sales. The inventory buyer can profit from the spread between total recovery and total cost. It can also lose money for exactly the same reason. And the retailer? The retailer may not view returns as a profit center at all. It may be minimizing loss, protecting customer loyalty, recovering inventory value, and controlling fraud. One public example shows how material the estimate can become. Urban Outfitters reported a $90.4 million liability for expected sales returns at the end of its 2024 fiscal year, compared with $80.5 million a year earlier. That does not tell us how much the company ultimately lost. It shows that expected returns are large enough to be estimated and recorded before every physical item arrives. This gives us the simplest way to read the entire industry. Follow the invoice, then follow the risk. If a company is paid a defined fee for moving, inspecting, or selling an item it does not own, its risk is mainly operational: labor, accuracy, volume, service levels, and contracts. If a company owns the item, advances money against it, guarantees its value, or buys it without inspection, operational risk becomes inventory risk. The service provider asks, can we perform this task for less than the fee? The inventory owner asks, what will this uncertain object eventually be worth? Those are completely different businesses, even when they operate in the same warehouse. The size of the return economy does not mean a small operator can simply claim a piece of it. A national return network needs software integrations, retail relationships, transportation density, security, claims processes, and reliable coverage. A general-purpose return center needs facilities, systems, trained labor, volume, and contracts before its equipment becomes productive. Those are scale businesses, but narrow service gaps can be testable. A specialist could focus on one product category where condition is difficult to evaluate and local retailers lack expertise. That might mean testing and securely wiping electronics, photographing and cataloging bulky goods, cleaning and repackaging a defined type of equipment, or preparing business surplus for auction. The word specialist matters. A company that accepts every category inherits every category's problems. The safest first test would begin without inventory speculation. Choose one narrow service. Identify 20 potential business customers within a workable radius. Ask what happens to their returns today, which items consume the most staff time, what mistakes cost them money, how volume changes by season, and whether they outsource any part of the process. Then design a paid pilot around one measurable result: processing time, accurate grading, recovered value, data destruction records, reduced storage, or fewer shipments. Do not begin by leasing a warehouse because the national market is large. Do not buy a conveyor because a public logistics company has billion-dollar revenue. And do not buy a truckload of mixed returns because the suggested retail value looks impressive. Start with the invoice you want to send. What exactly will the customer pay for? Per item? Per hour? Per pallet? A monthly minimum? A percentage of recovered value? Who pays for errors? Who owns the goods? Who pays transport? How quickly must items be processed? What happens in January when holiday returns arrive at once? If those questions have no answers, there is no operating model yet. For most first-time operators, a low inventory service is easier to test than a high inventory bet. It may look less exciting on a thumbnail, but it gives you a customer problem before it gives you a warehouse full of problems. Our Blue Jacket began as a simple refund. Behind that refund, software decided what was allowed. A collection network manufactured density. Processing center converted uncertainty into a grade. A retailer chose between restocking, discounting, returning to the vendor, or liquidating. And if a liquidation buyer purchased the jacket, the remaining uncertainty moved with it. So who profits after you return an online order? Potentially anyone who solves a measurable part of the process for less than the fee they charge. But the most stable position is usually not the person staring at the largest discount. It is the operator with a clear contract, repeatable work, controlled liability, and little exposure to whether one uncertain item sells. That is the test we will use throughout this channel, not how much money moves through an industry, but who can invoice for a real service, who does the hidden work, and who is left holding the risk. If you had to choose one side of this system, would you rather charge to inspect the returns or buy the inventory and resell it? Tell me which one, and what number you would need to see before saying yes.